Now, I know some of this stuff will be stuff that you guys have already covered or that you should have covered in math, but we have to make an assumption that, not everybody's at the same level. So it's going to go a little slow in the beginning, but it'll pick up, okay? So are you guys familiar with scientific notation? Yes, no, maybe?
Yes.
Yes.
It's pretty straightforward, I feel.
Okay, that's great. Pretty straightforward. So the standard forms for scientific notation is your coefficient here. In this case, we have four number coefficient here. So it's typically a standard. One represents that first number. So you have a single number, and then you have numbers following it, right? And you could have any range of numbers. Here we would have 4 numbers. There could be 5 numbers. There could be 10 numbers. That would be in your standard coefficient. But the key is that you have only a single digit in the ones spot. Then you have the exponential. So coefficient, and this represents your exponential, and E is to the power that exponential is. So if it's the 100th power, you'd put 10 to the second power. If it's 1,000, then it's 10 to the third power, so on and so forth. Okay. If it's to the 100th power, it's 10 to the -2. Okay. So whole numbers are going to be given in that exponential in most cases. Okay. So the way that we would normally go about doing this is that, let's say we have a number that is in decimal form. This number here represents a decimal form. Example. So in this situation, your decimal technically would be right here, right before the 1 spot. So then all you would do is count 1, 2, 3, 4, 5, 6. So then your answer in this situation would be 3.67219 times 10 to the 6th. Simple? Yeah, no, maybe?
Yes. And then you will be, my guess is in a few slides, you'll also be going over like significant numbers.
Significant figures, yes, I will be.
Or figures, yeah, sorry.
Okay. So going back the other way, so in this case, we want to, again, count where the decimal's at. And then this way we're going towards the right. So that's 1, 2, 3. So this number would be 4.61 times 10 to the -3. Simple? Okay, so I did the first one. Who's going to help me out with one of these? Let's see, Aaliyah? You want to do the first one? And Alexandria, do you want to do the second one?
Okay. Do I use a whiteboard?
Yep, you can write on my board. Do you remember how to do it? So Alexandria, so your answer is correct. However, one of the reasons why we use scientific notation is so that we don't have to carry all those zeros. So since that's the case, oops. There you go. That would be our answer. Did I erase your answer, Aaliyah? Now, Aaliyah, we want to have one digit, then the decimal, not two digits. Okay. So that's 1, 2, 3, 4, 5. Beautiful, good job. So the way Aaliyah written it, so this is the way that you would have to type it under the circumstances since we can't do superscript. So this just basically means to the -5 power. Okay, good job. Okay, so now if we're converting, so that was basically converting decimal to scientific notation. But if we're converting scientific notation to decimal, let's see, Brian, do you want to do the first one? And Caitlin, do you want to do the second one?
The only thing is, my computer doesn't let me write on the whiteboard.
Okay, so then tell me what I need to do for you.
All right. Let's see.
So I have 3.47. So what do I need to do with the decimal?
Move the decimal point 11 times to the left with zeros.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's 0, 0, 0. Brian, I think you're messing with me. I think you actually are able to write. You just don't want to write all those zeros.
Oh, nah.
So the decimal is now here. And then I like to put a 0 in front so that I know. Okay. Piece of cake.
Yeah.
Caitlin, are you there?
Yeah, it would basically do the same thing, right?
Okay. So which way are you moving the decimal?
To the left.
To the left. This is a positive number.
Oh, and then to the right.
Okay. 1, 2, 3, 4. Okay. Piece of cake. Okay, so how many of you guys use your calculators or have calculators? All of you? So at some point you want to get a calculator. So you want a scientific calculator. On your scientific calculators, you'll have a button that says EE. So that basically represents the exponent, or it'll say EXP, which also represents the exponent. And occasionally some calculators have 10 to the X. That also represents your exponent as well. Okay, so when you're entering your calculator, entering things in your calculator, you'll do the decimal version or the coefficient. So if it was like 1.21, the EE button or the EXP button, let's say it's 1.21 times 10 to the negative 5. There's another button that either it'll say plus or minus, or it'll have a minus in parentheses. Either one of those buttons. And then you put 5. Okay. Okay, so when we're talking about quantities are basically made up of a value and a unit, right? So you can't just tell me you have 27, right? So what does that mean? Do you have 27 wives? You have 27 girlfriends? You have 27 feet? You have 27 milliliters? What is it that you have? Right? So you always want to make sure that you include the units that you're working with so that we can follow the units. So if we have, let's say, express 50 minutes in 60 seconds. So this allows us to do simple conversions if we know what units we're working with. Here, what are the units that were given?
Minutes and seconds.
So are we given minutes and seconds? Or are we given minutes?
Yeah, we're just given minutes.
So we're just given minutes. So this is our given. So typically, when I set up a problem, I always want to start with my given. So 50 minutes. And I know that I want to get seconds. So what I would do is set up a nice little table. So let me ask you this. If I have x over x, what does that equal?
1.
What about x squared over x squared?
Is that still 1?
Still 1, right? So
Yeah.
regardless of what I put, if I have that number over itself, it's always going to be 1, right? That's nothing new. That's something that we all know. So then if I put seconds over seconds, what is that going to equal?
One.
Seconds.
Okay. Not seconds, it'll just be 1. It will be dimensionless, right? You lose those units. So those units are able to be canceled out as well. So we can use the units to sit there and track our answer to make sure that we're on the right track. So knowing that, I know that how many seconds are in a minute?
60.
So I know that I could put 60 seconds here over 1 minute. So that's an equivalency, right? So we know that 1 minute equals 60 seconds. So I can put it in this manner, and then that will allow me to cancel out my units. So this concept is called dimensional analysis. Okay, piece of cake.
Will be with practice.
Okay. Okay, so let's see. Let's test out those skills. Since you said we'll be with practice. So the oldest oldest horse racing track in the United States is the 8-furlong Pleasantation Fairground Racetrack in California. What is the length of the track in rods? So what's my given?
8 furlong.
And what do I want?
How many? What is the length of the track and rods?
Okay, I want rods.
Mhm.
Okay, so what am I going to start with, Jason?
By making the chart, so you have 8 furlongs total, and then 1 rod would be divided by the 0.025 furlong, because it's
Okay,
0.25 for each rod.
so you said run rod. Okay,
So then the furlongs cancel each other out, and then that means you could divide the 1 by the 0.025 and then multiply it by 8, I believe.
okay. So what will that be?
So I can't do that in my head. So so it'd be the division part would be 40, and then when you multiply it by 8, it's 320
Okay,
rods.
Piece of cake? Okay, so let's move on. Okay, so we know that 60 seconds equal 1 minute. So that was an equivalency. And since we have that equivalency, we can sit there and adjust that equivalency any way that we need to adjust it. So I could always say that, you know, as we had written earlier, we had 60 seconds on top. And 1 minute on the bottom. Or I could have written it as 1 minute on top. And 60 seconds on bottom. So depending on what was my given, I can make that adjustment, okay? So I can do this with conversion factors or equivalencies when I say things are equivalent, okay? So, for example, 1 day is 24 hours. So how many different ways can I write that?
You can
Could you-
do 1 day over 24 hours or 24 hours over 1 day.
Okay. Okay. What about when I have my car averages 17 miles per gallon?
Could do 1 gallon over 17 miles or 17 miles over 1 gallon.
Simple? Okay,
Yes.
let's keep going. So, see if we can make it a little bit harder. So this is just the steps or the algorithm. Algorithm are steps that you would take to do something. So these are just the steps that you would take to go through and solve your problem, right? We have an idea of how to do it. Not too hard, we can work through it, right? So we won't go over the details. They're here for your benefit if you want to take a look at them later on. So let's see. Jacqueline. Let's see, calculate the number of weeks in 672 hours. So what's my given?
672 hours.
Okay. And what do I want?
The number of weeks.
Okay. So we're going to start off with our given, 672. And at the end, I want to have the number of weeks. Okay, so what do we know about hours? What are some equivalencies that we can use for this?
24 hours in a day.
Okay, 24 hours in a day. So am I going to put the hours on top or hours on bottom?
On the bottom.
Okay. So 1 day on top. And what do we know about days and weeks?
There's 7 days in a week.
Okay, so I'm assuming that we put 7 days at the bottom. Getting ahead of myself. So a week on top. Okay, so what's our answer? So if we follow our units, we should end up with the same units that we're looking for, which is 4 weeks. Piece of cake. Not too hard, right? Easy so far, right? Good. See if we can make it a little more challenging. So what is the distance expressed in miles? Will an automobile travel in 3 hours at an average speed of 62 miles per hour? So let's start. Jennifer, you gonna help me out with this one?
Sure. So the given is an average, 62 miles per hour. Hold on, let me think about this one really quick. So we need to find out what the car will travel in 3 hours. So if the average speed is 62 miles per hour, so it's 1 hour over 62 miles.
So is that what I'm gonna start with? Or is that my equivalency?
Oh, that's your equivalency.
Okay. So then what am I gonna start with?
Let's see. Will it be 62 over 1? Or no? 2 hours.
So let's read the
Sorry, I
question.
swear I was paying attention. I'm just having a little hard time with this one.
It's okay. It says, what distance expressed in miles will an automobile travel in 3 hours at the average speed of 62 miles per hour? So where am I going to start off with? What am I given?
3 hours.
3 hours. Okay, so I'm going to start with my 3 hours.
Gotcha. Sorry. Thank
Oh,
you.
that's okay. It's a learning process. We can all be at the
Yes.
same speed, unfortunately. Okay, so now we can use our equivalency. So am I going to put the 62 miles on the top, or am I going to put the 62 miles on the bottom?
On the top.
On the top. And then that means by default, the 1 hours are going to go on the bottom.
Yeah. So then the total will be 186 miles.
Okay.
Since we cancel out the hours
Sure.
in the dimensional analysis. That was easier than I thought. I thought too much into it.
That's usually what happens. Or you get caught up in the word problems.
Well, thank you for your help. I appreciate it.
Yeah, no problem. That's what I'm here for. Okay, so you guys ready for the next one? So is it Viria Diana? How do you pronounce her name?
Vidi.
Vidi.
Yeah.
Okay, so you're gonna make it easy for me. Okay, Vidi, help me out with this one. It says a little girl broke a piggy bank Inside she found 2,608 pennies. How many dollars does she have?
Aren't you supposed to divide it?
Divided by what?
Well,
So where
100
am I going to
pennies.
start?
100 pennies is $1.
100 pennies $1. That's my equivalency.
Mhm.
Okay, so I have, my starting point is going to be 260 pennies. I mean, not 200, 2,608 pennies.
So it's 26.
26 what?
$26.08.
Okay. Okay, so pretty simple, right? You guys kind of get this? Not a problem? Okay, so let's say we had something like 93,215 minutes, and I want it converted into years. So convert. Let's see, Norma, are you gonna help me out with this one?
I can try.
Okay,
It's minutes into years. 365 days is 1 year.
so we have 365 days equals 1 year. Okay, so that would be one equivalencies.
Mhm. I'm sorry, I'm still trying to think. Days, minutes. I'm sorry, I'm drawing a blank right now.
That's all right. What else? What other conversion do we need?
Oh, we need to get minutes.
Okay, minutes to what?
Minutes, I think would have to go into hours.
Okay. And how many minutes are in an hour?
60.
Okay. So, and what about, because we have days here, so how do we get to days?
Wouldn't we, wait, how do we get to days? Wouldn't we?
Yep.
There's 24 hours in a day.
24 hours in a day. Okay, so we have 3 equivalencies to work with. So what's our given?
Our given's minutes.
are given as a minute. Okay, so we have 903, I mean 93,215 minutes. You think I can remember the problem since I wrote it. Okay. And so which one of my conversions am I going to use next? What's going to help me get rid of my minutes?
I feel like the 60 minutes, so the hour.
Okay. So am I going to put the minutes on the top or on the bottom?
You're gonna put them on the bottom so they can cancel out.
Okay. And then 1 hour top. Okay, then what am I going to use next? So that cancels out my minutes. Now I have hours.
Then you need to use the 24 hours.
Okay. At the bottom again.
Yeah.
And then what am I gonna put on top?
The 1 day.
Okay, and then we're gonna use.
So we're gonna cancel out the hours again.
Okay. So now we have days.
Yeah. So then we use the 365 days, and that the 365 will go on the bottom and the year would go on the top. And then you would cancel out the days.
Okay.
So the only thing we have left is years, and that's what we wanted.
Yep.
Then wouldn't we just multiply?
Okay, so we multiply across, and then divide by the numbers at the bottom.
Yeah.
So what do you get?
Math isn't my strong suit, so give me a second.
Okay.
So multiply the top. That one will be the same. Then divide. So divided by.
What did you get, Norma?
Wait, I'm still like thinking here.
Okay.
Okay, I don't think what I got's right.
Well, tell me. You'll be surprised.
No, because I got like a bunch of decimals, and I was like, okay, that's not it.
Huh?
I got
So
decimals, but I think I did it wrong.
so you started with 93,215. You
Yes.
divided that by 60, right? Then you divided that by 24. Then you divide that by 365. So your answer should be 0.
Wait. Oh my God. 177, 34, 94. Number 97, I mean.
That's correct. Gonna put days. Piece of cake? So we can use multiple equivalencies to get to a point, starting from one point to get to the point that we want to get, right? And that's the point of the problem, okay? Questions, concerns? Good. This is an easy class. It's always good to have like 5 people or 10 people. It makes it so much easier. Okay, so in science, we traditionally use the metric system. One of the benefits of using the metric system is that it's base 10. Okay, unlike the imperial system, which is what we use in the US, so feet, yard, you know, what is it, inches, feet, yards. So how many inches are in a foot?
12.
How many feet are in a yard?
3, I believe.
3. How many yards are in a mile? Yeah, that's my point, right? So it's not this nice little multiple of 10 type of situation. You have to sit there and really put a lot of things to memory, put a lot of effort in, right? So the metric system is a great system in comparison, right? Compared to that 3 feet, 12 inches, so on and so forth, right? Makes it so much easier when you're just working with multiples of 10, right? Because we know that, let's say a centimeter equals 100, or 100 centimeters equals 1 meter. We know that 10 millimeters will equal a centimeter, right? So it's easy to work with that base 10. So the beauty of the metric system is that we can apply it to various types of measurements. So if we're doing mass, we can use grams and then use the metric system as our units or our prefix, okay? So for instance, grams represents mass. Meters represents distance or length. And liters represents volume. So this is going to represent our base or our units. So these are the prefixes that we would use. So if we have 1 gram, and I'm going to use a G for my abbreviation, is going to be equal to 10 decigrams. $10 grams is going to equal to 10 decagrams or dags. A 100 grams is going to equal, oops, sorry, I said 10. Sorry, that should be 1 decagram. Is going to equal 100 grams is going to equal 1 hectogram. A 1,000, well, it's a rough morning, or not a morning, afternoon. Put too many zeros there. A 1,000 grams is going to equal a kilogram. A 1,000,000 grams is going to equal a mega, capital M, gram. a billion grams is going to equal a gigagram. A trillion grams is going to equal a teragram. Now, the beauty is, if we were talking about length, we could use meters. So we would say 1,000 meters equal 1 kilometer or kilometer, okay? On the other side, as I was saying, 10 decigrams equal 1 gram. 100 centigrams equal 1 gram. Say 1,000 milli, and we'll use meters here just for the hell of it. Millimeters equal 1 meter. A million micro in the mu. So this letter here, this is a Greek letter called mu, mu, but it means micro. So micrometer equal 1 meter. A billion nanometers equal 1 meter. So, and a trillion picometer equal 1 meter. Okay, so you see the trend? Okay, so the difference between mass and weight. So mass is going to be the same regardless of where you're at. Where weight is dependent on gravitational force. Okay, so on Earth, I'm going to weigh differently than I would weigh on the moon. Okay, the moon is 1/16 of the gravity of the Earth, right? So then I would weigh 1/16 less than I would here on Earth. So if I weigh 220 pounds, we divide it by 16, and then that's what I would weigh on the moon. Okay, so we want to calculate mass because we want the mass of things in most cases. And so often we will use the term weight, interchangeable for mass, but they're not exactly the same thing. Okay, so you guys understand that as well? Okay, so SI units are the standard international units. So this is a set of units that the international community got together and said, hey, this is going to be the standard unit. When you're reporting things for certain things, you're always going to use SI units. Okay, now, so there's going to be some variation because, of course, we're the US and we like to be rebels, right? And so because of that, you need to be aware of all, the empirical units as well as the SI units and how they relate to each other. So that's going to be kind of important to understand. So the SI unit for mass is kilograms. So kilograms is the units that the international community goes for. But often, if you're not working with large quantities, right, that are kilogram worth measuring, we will often use grams because it's a smaller quantity than a kilogram, because we know that 1,000 grams is going to equal 1 kilogram, right? So often, if I tell you to measure 5 grams, you're not going to give it to me in kilograms because you don't want to carry all those zeros, right? So you would often just measure it in grams, okay? So the SI units for length is meters. So, and that's, again, the standard units that are going to be used. So if we're measuring very long distances, we're going to use kilometers. If we're using very small distances, we're going to use centimeters or millimeters, right? So if you're just measuring the length of your nail, you're not going to give it to me in kilometers, are you? Most cases not. Okay, so a kilometer is approximately 2.2 pounds. So I'm writing my tender profile. I want to use SI units. How much do I weigh? Kevin.
Can you repeat the question?
So if I'm writing my tender profile and I want to use SI units to put my weight in, so how many kilometers do I weigh? So I weigh 220 pounds and I want it in kilograms.
So you would your given obviously is 220 pounds, and then to convert it to kilograms, you would multiply and have to divide by the equivalence ratio, which is 1 kilogram over 2.2 pounds.
Okay.
And when I calculate it, it gives you 100 kilograms.
Okay. So 220 pounds, 1 pound. Oops, I'm sorry. 2.2 pounds equal 1 equals 1 kilogram. So I weigh 100 kilograms. So I'm definitely going to put those units there, right? Because otherwise, if I say in my profile, I weigh 100, right? What are most of the girls going to think when they see my profile? I'm 5'9", I'm hunkish, and I weigh 100 pounds.
But you're probably very emaciated.
Okay, so in normal terms, I'm really, really skinny, right? Okay, so probably not going to get the woman that I want, most likely, because most women that I know want a thicker guy than 100 pounds when he's 5'8", or 5'9". Okay, questions, concerns? Cash? Okay.
Only if you're handing it out.
Only one. I'm saying that you were giving me cash. I don't give out cash. I'm broke, so. Okay, so now often, like I said, we're going to have to do conversions between empirical units and SI units. So we also need to know the conversion between an inch. An inch is going to be 2.54 centimeters. And if you look on your resource tab under modules, you have a list of conversions. Those conversions are going to be yours to use for the exam. Because in most cases in real life, you're going to be able to Google it when you're in doubt, right? Anytime that I forget any conversion, the first thing I do, I hit Google and I go, inches to centimeters or whatever conversion I'm looking for. Okay, so you're going to have a table. It's going to be yours to use. I'm not going to say you can use Google on the test, but you can use the conversion sheet. Okay, so so the common units, or the SI units for volume is cubic meters, which is surprisingly because we often will use liters in scientific notation rather than cubic meters. So you'll see liters more commonly used and milliliters more commonly used than cubic centimeters, even though that cubic meters are the SI units. And you guys understand what volume is. Volume just basically represents the space that's being occupied by the given piece of matter. Okay, and so this table basically just shows you the equivalency of a cube, 1 centimeter cube, relative to what it's going to equal in terms of a liter and what it is in terms of a milliliter. So have you guys heard of cc's? 5 cc stat. So cc stands for cubic centimeters. So 1 milliliter is equal to 1 cubic centimeter. Okay, so when you see that syringe that says 5 cc's, that's 5 milliliters. Okay. Okay, so with the metric system, we can also set up conversions as well, right? So whatever units you're using, whether you're using distance or you're using mass or you're using volume, you can sit there and say whatever unit it is, 1,000 of that unit is going to equal to 1 kilo of that unit. Okay, and that can be done either direction, right? Just like any other conversion. Okay, so let's see, who haven't I picked on yet? Steve, you've been pretty quiet. Help me out with this one, Steve. Okay, so how would I start? What's my given?
0.711.
So don't forget the units. Okay, and you said it's how many grams are in a milligram? I mean, in a kilogram?
How many would you say grams are in a kilogram?
Yeah, how many grams are in 1 kilogram?
Ooh, 1,000.
Okay, 1,000.
Yeah.
So 711 grams?
Yes.
Yes. Okay. Cool. Piece of cake. So the hardest part is remembering all of the different conversions, like micro, right? Or kilo, or mil. How many of you guys, do any of you guys speak Spanish?
I do.
You do? So what does mil mean in Spanish?
Mil is 1,000.
1,000, right? So if I say millimeter, you should think 1,000 millimeters in 1 meter, right?
Yeah.
Yeah. Okay, so let's see. If we're going the other way, we have 5.25 times 10 to the 5th milligrams to kilograms. So how am I going to set this one up? Any volunteers?
Well, do you first need to, I don't know how to say it, but take it out of scientific notation?
So do I have
You-
to take it out of scientific notation?
I don't know, to be honest.
No, I mean, we could technically leave everything in scientific notation, right?
Okay.
Okay. So let's just leave it the way it is and we'll see how it comes out.
Okay.
Okay. So let's go. It's 5.25 times 10 to the 5 little m g. Okay. So which conversion factor am I going to use?
How many milligrams are in kilograms?
How many milligrams are in a kilogram? Is there anything that I can go in between that?
Grams. Grams.
Grams. So how many milligrams are in a gram?
Let me look at my paper here.
Bet you somebody knows. Mil.
Oh, 1,000.
Yes. So is that going on top or on the bottom?
The milligrams?
Yep.
Yeah, that's going on the bottom.
Okay. Sorry, I get ahead of myself and I just start writing. Okay, so that means I have 1 gram on top.
Uh-huh.
Okay, so then how many grams are in a kilogram?
1,000 grams are in a kilogram.
Okay, so now I'm going to put the...
On the bottom.
Okay.
Yeah.
And so 1 kilogram on top. Okay, so that's 1, 2, 3 zeros here. That's 1, 2, 3 zeros here. So if I have 3 zeros and 3 zeros on both of those, so I can add those 2, 3 zeros. So that'll be
billion.
Okay, so then if I go ahead and do this, this will be 5.25 times 10 to the minus 1 kilograms. Or I could write it as 0.525 kilograms. Both answers would have been fine. So I could have left in a scientific notation.
How did you get that from the problem? Like, so there's a million on the bottom.
Mm-hmm.
And
so that's 10 to the minus 6, right? And this is 5.25.
Oh, okay.
Sorry. Times 10 to the 5.
Yes.
So because it's division, yeah.
You subtract it, yeah.
Yeah. So that same thing as saying 10, 5 minus 6.
Mm-hmm. Gotcha.
Okay.
Thank you.
No problem. Okay, questions, concerns, Cash? I take Venmo too. Okay, so a fruit drink is sold in bottles that contain 1,892 milliliters. express the volume in cubic centimeters and in liters. Any volunteers? Or do I have to voluntold?
In cubic centimeters, it's the same thing, isn't it?
That is correct. In cubic centimeters, it is exactly the same thing, because we know that 1 cc is equal to 1 ml. Okay.
And in liters, you could multiply it by 0.001.
Okay. So, or yeah, so we could go at 18.
Or did you want to set it up like on the
Well, it's up to you. I mean, you could go, as long as you get the answer at the end, I don't care how you do it. And as long as I can see how you got it, right?
Yeah,
so you could do it the hard way, since we know that there's a 1,000. And 1 liter. But you just want to make sure that you end up with the right number. The reason why I have you setting it up this way, because this is going to be, I say things are bread and butter of chemistry. This is going to be one of those other things that are going to be bread and butter of chemistry. You're going to be doing so many of them that you're going to be sick of it at the end. And then they're going to get a lot more complex. Okay, questions, concerns? No concerns? Keep going. Okay, so sig figs. Okay, so when we're talking about significant figures are about uncertainty. So remember when I told you guys that I weigh 220 pounds? So I have a scale at home. How many of you guys have a scale at home?
I do.
Okay, so one person out of everybody there have a scale at home. That's good to know.
I raised my hand. Maybe you didn't see me. Sorry.
Oh, I didn't see you. Sorry, my bad.
It's okay.
Okay, so 2. Okay, so I'm a little vain. I'm not gonna lie. So I weigh myself frequently and everything like that. And I'm trying to get my rip tone, abs, and all of that, right? So I've been exercising a little bit. So I go and I weigh myself a couple times during the day. But the first time I weigh myself, it's let's see, I get 225. Not too bad, and stuff like that. I'm toning down a little bit. I'm losing the badonkadonk, trying to make it into muscle, So I'm like, okay, yeah, not too bad. I go and I weigh again. I get 218. I go and I weigh again. I get 220. I go and I weigh again. I get 223. So I go and, I weigh one more time and I get 228. Okay, so is my scale certain? It's doing all of that fluctuating. Where is it fluctuating at? The ones or the 10 spot or the 100 spot? Ones being this last number, 10 spot being in this number, and the 100 spot being in this number. Okay?
The ones.
The 1 spot. So it's fluctuating in the 1 spot, right? So I just said, oh, since we're not certain about that 1 spot, and I want to make myself look a little bit better and feel a little bit better about myself, what do I tell you I weigh?
220.
I said 220, right? So because I know that that last number is uncertain, it could be 218, it could be 220, it could be 223, right? Who knows? We're not sure, right? And so how do you accommodate for that, right? There's 2 ways, right? So one of the ways that we could accommodate is by making a plus or minus value. We could take the average of those numbers. So if we take the average of those numbers, what do you guys end up with?
222.8.
Okay, so we can take that average, and we know that we're kind of fluctuating in the one spot, right? So we're just going to leave it as this 8 here. We can round it up, we can round it down, so we can say 223. Okay, 223. So plus or minus, how much am I fluctuating? So what's going to give me my 218? Five, roughly.
Yeah.
Okay, and what's going to give me to my 228?
5 roughly.
So plus or minus 5. Okay, so that's one way that we could sit there and account for that uncertainty. So my scale, so really I should say I weigh 223 plus or minus 5, right? Now you get tired of saying that after a while. I'm 223 plus or minus 5. So what am I going to do, right? So let me show you another way. Because we're uncertain for that last figure, we can sit there and we can say, well, this figure here is totally uncertain. That one spot is one uncertain. So since it's a 3, I can just say 220. And that means I have 2 significant figures. That 0 isn't significant. So that basically means that that 0, I'm not quite sure about. It could be a 0, it could be a 3, not sure, okay? And so I just put a 0 there. So then that's why I tell you I weigh 220, because I'm not sure about this very last number, right? But I'm certain about the 220 component of it, but I'm not quite sure about that last one. Okay, so in this case, that gives me 2 significant figures. So I'm going to go to the whiteboard. Then we'll be wrapping up here in a second. So
I have a question.
Yep.
So if it was, let's say, 202, so 202, would the 0 count as a significant figure since it's between the 2 significant figures?
that is a good question. We're going to get to that.
Oh, okay.
Okay, sig figs. Okay, so in this case, that's 2 significant figures. If we have 202, that would be 3 significant figures, because here, this 0 is in between 2 numbers. It's called a captive 0. It's caught between the 2. So then that would be 3 sig figs. This guy here, how many sig figs?
1.
Okay. Okay, in this case, these zeros are leading zeros. These are kind of space holding zeros, right? Just like these guys, these are space holding, these are lagging zeros. So leading and lagging zeros don't count towards your significance, okay? So this guy would have 1 significant figure. Now this guy is different. By you putting a 0 after the 2, and there's a decimal here, that says that my instrument is so good that I am sure about this 0, right? Otherwise, I would just leave it as a 2, like up here, right? So in this case, this guy would have 2 significant figures. And that's the same thing in a situation where we put a decimal here. We're saying, I am sure about that 1 spot. it is really 2,000. Okay, so then this guy would be 4 significant figures, compared to this guy would be only 1 because you don't have that decimal there. Okay, so if I do this, that would be 5 sig figs. Okay, because again, I put a decimal here and I took the time to pick that 0 there. That means I am really sure about that and about that tip spot. Okay, you guys get that? Not too bad? Not stressing you out yet? Okay, so let's see.
This helps out a lot.
Let's see those skills. Okay, so the first one, how many sig figs?
Anyone can answer?
Anyone?
7.
Okay, that's correct. And sig figs are short for significant figures. I haven't said that yet. Okay, what about the second number?
Four.
Third number?
Five.
Fourth number?
Why is it 5?
Because you have 1, 2, 3, 4, 5. These leading zeros, these are not significant. This one here, you're saying that I'm sure about these by adding them.
Oh, so when there's zeros in that area to the right of the decimal point, it's only the ones that are after the numbers that are higher than 1 that count, not the ones that are to the left of that. Okay.
Yep. Yeah. Okay, what about number 4, the fourth one?
1.
And the last one?
7.
Simple? Good, good. Okay. So, okay. That's clear. Any questions? Okay. So let's say we have this number here. Okay, let's say we have this number here, and we want 3 significant figures, just 3 significant figures. So we would take these first 3, that's going to be my 3 significant figures. We're going to look at this number right here, the fourth number. Now, if that fourth number is greater than 5, we're going to round up. So we'll round this number to a 4. Okay. If it's less than 5, then we leave this number alone and we put just a 0 here. Okay. And then if it's equal to 5 and there's no trailing numbers, then we leave that number alone and put a 0 here. If there's any trailing numbers, let's say, no. If there's a trailing number anywhere behind here, then we round up. Okay? Okay, so 3 sig figs. We want 3 sig figs. So then our answer is going to be for this number, for the first one. For the second one, it would be for the third one, it would be oh, I forgot a 0.
Can you repeat what you said about it being a 5 for that first problem? How
For the
the
first
fourth
one?
number?
Okay, sure. Hold on. Let me add one more, and then I'll re-explain it. Okay, so here, since we're looking at the 3 significant figures, 1, 2, 3, we take that fourth number, right? And if that number is 5, greater than 5, then we're going to round up. If it's less than 5, then we're going to leave it alone, put a 0 here, and leave this number alone. Okay? If it's equal to 5 exactly, if there's no numbers trailing it, then we're going to round down. So then it'll be 2, 0, 3, 0, 0, 0, 0, like we showed.
Got it. Well, thank you so much for explaining.
I have a question. So
Yep.
by trailing it, do you mean numbers that are after the decimal point?
No, numbers that are after the 5. I could have a number here, or I could have a number after the decimal point. It doesn't matter, right? Anything that just pushes it slightly over, okay? So here, let's see. Okay, so this first number, because that's a 5, we're gonna look to see if there's any numbers trailing it. If there's numbers trailing it, then we'll round up. There's no number trailing it. These are 0, 0, 0, right? So then we're just gonna leave it alone. So it'll be 2, 0, 3, 0, 0, 0, 0. Okay. Here, since there's numbers trailing the 5, so we have a 5 here. We have 1.0001 trailing it, right? So in that case, we're going to round up. So that'll be 2040000. Here, since this number here is less than 5, 2030000. Since this number is greater than 5, we'll have 2040000. And you don't want to forget your space holders. Okay? Kind of like, let's say I'm paying you money, right? Do you want $204 or do you want, what is that? $2,040,000. I guess you guys don't want anything. That makes it easy. So you guys can work for me anytime since you guys don't want any money. So, okay, piece of cake.
Thank you.
Okay, so I guess this is a good stopping point.